So anyways, square root 2 over 2 will be with a negative sign for y, as well as if you look at another coordinate that you don't need here, the x coordinate is also going to be square root 2 over 2, and since it's in the so-called third quadrant, it's also with a minus sign. Okay, so I have a square root of 2 over 2 to work with. So in this exercise, it's a little bit simpler because you don't really have to deal with colon sign with a theta. You just find what it is. In fact, it's not theta, it's just some number. And now, when I have a square root 2 over 2, I need to find arc cosine. And remember, the key part was to remember the domain and the range of functions arc cosine and arc sine. So if you remember function arc cosine, or it's a good idea to have the access to the graphs, which you will, because you're going to take home exam, and this is going to be, I guess, you're going to have plenty of time for it. So the range of this function is from 0 to pi. So whenever you have various values of it to deal with, let's say negative square root 2 over 2, then we gonna need to look at the 0 to pi angles. And if you have a negative square root 2 over 2 applied to cosine, we already saw the angles that correspond to it will deal with 45 degrees. And this angle then will have 145, 245, 345. So we're gonna end up with something that is here, 3 pi's over 4. So the answer is 3 pi over 4. And that's really all it is in here. So you got yourself a nice little angle. So I've done quite a few of these exercises already in this group of problems. And the advice is look back at the previous lecture recordings, because the midterm that we're going to have next week on Monday, actually, sorry, next Tuesday, we don't have class on Monday, on Tuesday, will contain one of the problems from this group of exercises. So I think I already done plenty of them. And advice is look at the examples that I shown to you, and that be your practice plan. So this is exercise number 2, and I also emailed to you the midterm exercise number 1. So let me try to find this. So I go to send items, and I look for the 1114. That's how you can also find the emails that I sent to you. I just have too many emails here that related to the our class. So here's one with midterm practice. So let me work out this problem for you as promised. So on the midterm, you're gonna be asked to use last digits of your student ID. I think it starts with a 4, with a 9, not with 9, but it doesn't matter here. You just go 1, 2, 3, 4, 5, 6. So the last digit was 6 that I created, and that's what I use to do this problem. Now, if someone wants me to use some other number for last digit, just let me know. I will use the number that you tell me because problems will be pretty much the same. The plan of working out this exercise will be the same. So exercise number 1 will be using the last digit, and the exercise number 2, analogous to which I just did the problem here, as well as other exercises from this set, will utilize a digit prior to the last one, which in my example is called A, and it's like 5. So you need to have access to your student ID, and if you're not sure, then you can always log into the Zoom on Tuesday, and I can help you with this. So I was asked to use 2 instead of B. Looks like 2 will replace B in 2 places. So we're going to end up graphing something that looks like negative 2 cosecants of 3 pi x. Notice that when I add 2 plus 1, I get 3. And then plus pi and plus 2. So this is what I need to graph. So let us do this. The way we graph these functions is we utilize the fact that cosecant function is 1 over sine. So we actually need to graph function sine. That should help us. And then, so graph of function sine is what I'm going to keep in mind. So sine function has a so-called main wave that varies in between of 0 and 2 pi. So I need to put in between 0 and 2 pi the argument of this, whatever it's in the parentheses. And
I have a question. Shouldn't it be 3 pi while you have parentheses?
3 pi, yeah.
No, when it says like 3 pi x plus 3 pi.
I see here pi, so I copied pi. And then there's
Okay.
plus 2. So whatever is in there, I just copied it. So just put that thing the way it is.
Professor, a question. Why you use 3 instead of 6? Because I see the B is the last number, right?
Yeah, because somebody asked me to use 2.
Oh, okay.
Because I was giving people a choice, so which number to use instead of B. So somebody just sent me 2, so I used 2. It doesn't matter. So let's do it.
Thank you.
Okay, so we're gonna keep working by isolation of our letter X. So I'm gonna subtract pi's everywhere, first step. So now our left side is gonna deal with a pi, but the point of story is that X is coming out little by little, and that's what I'm really after. So I'm dividing now by this 3 pi to have only X left in the center. So once I divide it, looks like letter pi will cancel. Okay, so we're gonna have just a negative 1/3 on the left side and positive 1/3 on the right side. Okay, so between negative 1/3 and positive 1/3, now I need to think about the actual negative 2 multiplied by cosecant. So what happens now with a graph of a function when we deal with a range, or actually domain, between negative 1/3 and a positive 1/3? But now our amplitude changes because of multiplying it by 2, so we go from minus to plus 2. One more observation, that our function sine now it's not gonna start to go up. It's gonna start here, and it will actually go down, and then return back up, and then continue going down after it hits level of 2. In other words, it's flipped because of the negative that we had in front of it. Oh, I forgot to put -2. Maybe that's what you were telling me. We understand. So -2, well, it's still here, right in front. So looks like this little piece will definitely help me a lot to get a graph, but now what I want is to utilize the fact that we also add 2 at the end. Adding a 2 at the very end means we're moving the graph 2 units upwards. 2 units upwards means it's going to be hitting my x-axis here. So to graph this picture, I'm going to need definitely another little picture here so we can put our graph better. And now it's going to be moving this pink piece in such a way that it actually touches our x-axis, then it goes upwards and then it goes downwards to the level of 4, because it used to be a level of only 2 because it was a amplitude power function 2, but now we moved it up 2 units because of this addition, so now it's on the level of 4, the highest piece. And of course it repeats itself again and again, but this is not the function that I need, because remember we want to get a cosecant, which is the inverse sine. So how do I get the graph of that inverse sine function? Well, I have to put the asymptotes at those special points of intersection. I think this graph is very, very messy. Maybe I can just clear it a little bit nicer. So what we now need to do is points of intersection with the x-axis. Well, they used to be points of intersection with x-axis, will give us those asymptotes. And that's what I'm doing right now. So these points give us vertical asymptotes. And now finally, I will be able to get a graph of function cosecant. It's just pieces hanging above and below this sine function. And that's exactly what we call as a negative whatever 2 cosecant of that stuff, 3 pi. You don't have to copy it, but just make sure that you see the answers that I put in blue color. So that pink stuff is just to help you graph it, but the actual cosecant will be hanging these little pieces below and above. So clearly I have to mark these numbers such as 1/3 for the asymptote, so that's where it ends, and the negative 1/3, maybe I put some other color so we can better recognize it, negative 1/3, where it actually starts. So this little piece that we're gonna kind of repeat. And also I marked those upper and lower points, such as a level of 0 and level of 4. So this is like the lowest and that's the highest. So this is a little bit time consuming, but again, we did lots of graphing of this back at the end of chapter number 6. So look at those sections at the end of chapter 6 exercises, and that'd be sections 6.5 and 6.6, right? That's where they talk in very detail about it. And we actually also did that same thing. And then section 7.2, that's where the second problem comes from. So I would say first problem is actually from section 6.6, but I still recommend you to look at the section 6.5 because that's where all those techniques were developed for functions such as a cosecant. So the two problems is what we're going to have on the midterm that I will email you next week on Tuesday. So you will get it in your student email so you can work it out without any rush. Just take your time. I will log into Zoom, of course, on Tuesday. If you have questions, you can also log in and ask. If you don't have questions, you don't have to log into Zoom. You could just do the midterm and make pictures and email it to me. Some people already sent me pictures of practice midterm exam, and that's awesome. That's good that you practiced. I like that. And also homework will be due next week. So Tuesday, I would say, is a good day to send me before Tuesday if you already have homework. Some people already sent me their homework, and that's great. I was very happy. I give full credit for homework. So if I see your homework, I give you full credit. So just do something. I told you that you could select a couple of problems from each lecture, and I thought I conveniently put those lectures on this little YouTube channel. So if you want, I can share the link with you again. I'm sure I shared this link with you so many times, you probably already have this idea of how to find this, but still, for just in case, I can give you this link because you still don't know what the homework is. So from each lecture, I think I should clear this mess. It's too messy now. So for each lecture, I ask you to do a couple of problems, two problems, right? So you can look at these lectures that I put on the, those are our lectures. Those are lectures that I was given to you this semester. So like here, for example, I work out a couple of problems and you can just do the same ones. So we can see, for example, exercise number 23 done, exercise 29 is being done. So what you can do is just copy the same solution, and that'd be your homework for the first lecture. So what would be the homework for the next lecture? Well, you click on it on the next lecture, and you can do another couple of problems here, the same ones that I did, like, for example, number 37 and exercise number, whatever it is in here, was it 17? So that's what you should do for the homework. The last lectures, I didn't put at this Zoom YouTube channel yet. I will work on it. The last lectures, they appear in your emails. So the message is you should check your student email, because I know that people just check Canvas, and the Canvas does not have anything but syllabus and your grades that will be updated next Wednesday after I get your midterm graded and post grades for the midterm. And I also will update your class grades together with a midterm. So you need to check your MDC student email. So I have a feeling that some people never check their emails and have no clue what is going on. And it all refers us back to the syllabus. So you always need to read syllabus. If you're such a Canvas lover, there is a syllabus on it, and the syllabus has all the information you need about. Yeah, question. No.
So the quizzes you used to give us, that wasn't homework, right?
Quizzes I give you in class. So whatever you do in class is not what you do at home. So quizzes not homework. Quizzes is one thing. Homework is totally different thing. I can.
So from all the lectures that we have, which ones do you want us to do? 2 questions.
So from first lecture, you do 2 questions. From second lecture, you do 2 questions. Third lecture, you do 2 questions. Fourth lecture, and so forth. So you do 2 questions from each lecture.
Professor, I have a question. What if we use the questions that you solved?
Yes, that's what I keep saying. You can do the same.
Okay, so perfect. So we can use our notes.
Exactly the same. Yeah. So
Okay, perfect.
you have your homework here. See, that's why I'm just wondering. This is so many times I told you what the homework is. In fact, last time I was also talking about it one. So I'm just wondering, some people, well, maybe miss the class or 2 or all of them. But if you miss class, you have recordings. So watch those recordings. You say, Alex, I don't want to watch any recordings. I just want to relax. Well, you really want to do something to pass any class, right? So you have it all here. Plus, there are some last recordings, like the one that I'm making up right now, that Zoom does actually for us. You can find them all in your student email. So you just go to the student email, and all you need to do is type 1114, and you will get all the messages from me, but not in a send, because you didn't send it. I send it to you. I'm typing send in the send because I was sending them. I was not receiving. But you should get to your inbox and type 1114 inbox, this one.
Professor, when is the midterm?
So you go to 1114 and in your inbox, and you're gonna type the in your inbox 1114, and that way you will get all the emails that I sent you. And in those emails, you will see the links to the lectures. So let me finish with this, and I will tell you the midterm is going to be next Tuesday. So all the lectures
Thank you.
that I was sending to you, you're welcome. So I can go back to, because I was sending them, so I can go to send. So you will be able to see the links to those. Like, for example, here's the one, you see, on Tuesday, I sent you the link. I call it as October the 3rd. So you just click on that link and you will see what we did on Tuesday last time. So if you missed it, you should definitely watch that lecture, or at least browse through it. And it will tell you, and when we have a midterm, and the exercises that I did that were reviewed before the midterm. So I would say that this is extremely helpful and important, because otherwise, how would you do the midterm? And if you want to relax over this weekend, I know some people have better plans than trigonometry. Well, at least then next week on Tuesday, when you be taking this midterm, I hope, you can click on this link and on the link for today's lecture and watch those problems that I was solving, because you will get something very, very similar to those exercises. So I would say concentrate on this last 2 lectures because I was actually doing the review already for the previous time as well. And of course, from these lectures, you can see what was for the homework, so you can do a couple of problems while you were watching them and email me this as your homework. So again, homework should be submitted by email, and it should be either copied or scanned, or if you don't know how to do that, well, just go on campus library. They will help you to scan whatever you want to scan, and they will show you how to send it by email. So one needs to learn it, because on the final exam, it'd be the same exact thing. I will also ask you for homework. I will also ask you to email me your final exam. But please do this in 2 separate emails. So if you send me your homework, send it separately. The midterm, call midterm and send it separately. So this way I'm not going to mix anything. Because I had a number of people already sending me their work, and they say, oh, here's my midterm. So there's one page I put in front, and the other page I put somewhere in between my homework, and never mentioned it was the midterm exercise. I just asked, oh, I saw only one problem from midterm, sent me another. Say, Alex, I already sent it to you. So, well, if I asked, then send it again, because maybe you mixed everything together when you were scanning. So that's why it'd be the best thing to send me separately midterm and another email or a bunch of emails that will be called as homework. So that way I'm not going to mix in those pages, because sometimes people do the midterm and they do one exercise, they don't do it right. And they do something and I have no clue what this is for, and just totally offline. But if you send it to me, at least you will get some credit for trying. I always give credit for trying. In fact, remember I told you, show all work when you do these exercises. Send it to me for grading. So anyways, anything else?
Professor,
Yes.
sorry, I have a question. What are the sections you are gonna pick exercise for the midterm?
So we covered chapter 6
Mhm.
and 2 sections of chapter 7. So chapter 6, and then we did 7.1 and 7.2. 2 sections of chapter 7.
Like the entire chapter 6 and 7.1 and 7.2, right?
Yes, that's absolutely correct.
But you're gonna choose that you're gonna choose the midterm from those exercises.
I already told you where the midterm is going to be coming from. The midterm
Yeah, sorry, I didn't write.
7.2. I just did exercise from 7.2 and the other exercise from 6.6. That's what we did today all day long. If you just logged in, it's all in the recording. So check this recording because it's all there.
Yes. Okay.
One is from 7.2, the other is from 6.6. And I did pretty much same exercises.
Okay. Thank you so much.
Yes, yes, you're welcome. So if you look at the chapter 6, so if you plan not to watch any of these lectures, just want to do problems on your own, which is fine, you can do 1 from 6.2 from 6.1, 2 from 6.2, 2 from 6.3, and so forth. So 6.6, that's where one problem for the midterm comes from, and then 7.2 is the other section. So
okay, now I understand. Thank you so much.
yeah, you're welcome. So yes, you can have a link to the textbook if you wish to do it like that, and I can always share this link to the textbook. I hope you already bookmarked it or saved it, but if not, for just in case, I can always put this in chat, because I know it's been a while, but I hope that you do have access to it. So that's our textbook, the free one. So you should definitely have access to the textbook, of course. But you don't have to actually go to this textbook because it's all there. It's all in the lecture. So when you click on some lecture, you will have this textbook opened and you will see where we are, what section we're dealing with, what page it is on. So it's all in these recordings. I think that those recordings are more helpful because the pages of textbook are here for you also opened. And I also show you how to do problems, not just you have textbook and then you are on your own. Here, I'm showing you how to do the problems. So I think it's much better. But anyways, it's up to you. So I was about to stop to record, and if anything else, please let me know.